Hello, my name is Dr. Jay Kernton. I'm a mathematician and a math tutor. This video is for anyone who is just getting started studying abstract algebra. So I put a theorem up on the screen. It's called the canonical decomposition for functions. It's pretty useful when you're studying abstract algebra, but it's not always in the curriculum clearly, even if it's there in the background. So it's not about groups, it's not about rings, it's just about sets and functions. And the theorem says this: let f from a to b be any function. So a is the domain and b is the codomain. Define tilde, the relation on the set A, by the following rule. So two things in A are related if and only if they have the same image under the function f. And then what do you get? You get that tilde is an equivalence relation, so it is reflexive, symmetric, and transitive. And you get that f decomposes as follows. So f is equal to the composition of this function, and this function, where the first function from a to a mod tilde is the surjection defined by taking a and sending it to its equivalence class. The third function from the image of f to b is the inclusion of one subset into the larger set. And then the function along the bottom, f tilde, it's the bijection defined from the equivalence class of A to the image of A. So there's a lot here. It's kind of a mouthful. Part of the theorem is that the function f tilde is well defined and it's a bijection. But the main point of the theorem is this: any function, doesn't matter what function it is, you can always decompose it into a surjection followed by a bijection followed by an injection. So any f decomposes into surjection, a bijection, injection. So kind of similar to how any natural number can be decomposed into prime factors, any function can be decomposed into these three pieces. So kind of similar, but obviously pretty different. But kind of one way to think about it. So I'm not going to prove this theorem in the video. I'll put a link in the description of the video if you want to read through the details. But what I want to say is that in abstract algebra, there are all these isomorphism theorems, like the first group isomorphism theorem, and then there's the isomorphism theorems for rings and modules and all that stuff. All of those theorems depend on this theorem. So for example, the first isomorphism theorem for groups says that when A and B are groups and F is a group homomorphism, F tilde is a group isomorphism. So part of that is that the quotient has a group structure. There's an operation there. And the image also has a group structure. And the bijection that you already know is there because it's a function is also a group isomorphism. I'll put links with more information. I know this video is not very detailed, but hopefully someone out there finds it useful. That'll be that. All right, take care.